All right. Yeah, so this is live streaming now. So let's get started. So everyone, today we're going to go through quantitative reasoning, and that'll be pretty much it for today. I do want to ask you guys a favor. I'm a bit sick today. I'm not sure why, not feeling that great. Maybe it's the weather. So I hope you guys behave a bit extra nice today. But yeah, so we'll get started. So let's go through question number one in quantitative reasoning. So question number one, use the chart above to answer the question. Kaylee randomly takes a marble from a bag and records the color in the color chart, then returns a marble to the bag. She does this 30 times and records her results in the chart each time. The chart shows the results. What is the experimental probability of getting a red marble? So since it was, since she took it out 30 times, and out of the 30 times, she got red 7 times, the probability is just 7 out of 30, right? A quick way to, if you're not fully sure about probability, a way to think about it is the bottom number is always the total possibilities or the total number of outcomes that has happened, and the top is the number of times the outcome that you want uh, happened. So in this case, the top is the red, and the bottom is all the colors, I guess, all the colors or all the outcomes that's happened. All right. So let's take a look at question number two. I really like two. Two is a really good question. And it's something that requires you to, break it down and then do it step by step. But other than that, it's a fairly easy question. It's a fairly good question. So the first thing it says is that a semicircle of an area of 50 pi can fit perfectly inside a rectangle. So imagine this is my rectangle. Actually, I'll just draw a proper rectangle. This is my rectangle, right? And then it says that a semicircle fits perfectly inside this rectangle. Oops, it doesn't draw a semicircle, but I'll just draw it like this then. Oh, that's a terrible semicircle. How about this? All right, that's kind of better, right? So a semicircle fits perfectly inside of it. Now, you guys know that a semicircle literally just means half of a circle, right? So if half of a circle, if the semicircle, SC, meaning semicircle, is equal to 50 pi, then the full circle should equal 100 pi. Fairly straightforward, right? From there, like the reason why we're doing what we're doing is essentially we need to find out the length and the width. Now, we have some good news. The length is essentially the radius of the circle, and the width is basically two radiuses, right? Two halves of the circle. So if you just find out what the radius is, we can figure out the dimensions, and then we can find out the area. Now, to do that, we all know that the area, oops, let's make it a bit better. Know that the area of a circle is pi r squared. So since we know that, what we can do, let's see, okay, 4.5. I want to get this to about 3. All right, so I'm going to rub this out, redraw that. All right. We know that the area of a circle is pi multiplied by r squared. So since the area's equation is this, and then we know what the area is, we can equal them to each other. So what does that mean? It means that 100 pi is equal to pi r squared. Why is that? It's because, the equation is always, we know what the equation is and we know what the area is. So therefore, they're just equal to each other. Okay? So since they're equal to each other, we can now figure out how to find the radius. Both of them have pi on each side. So what I'm going to do, by the way, just to make it easier to follow through, I'll move this whole thing, copy. We'll go to a new page. We can do it here. Paste. All right. All right. So since we have this here, all right. So since it's on, okay, on both, since we have pi on both sides, what we can do is divide both sides by pi. So 100 pi divided by pi is equal to pi r squared divided by pi. And when you divide both sides by pi, you cancel the pi's out, and you're left with 100 is equal to r squared, right? 100 is equal to r squared. And what number multiplied by itself will give you 100? R is equal to 10. So the radius is equal to 10. Now, since we know that, we can go back to this page and we can fill the thing in. So now we know that the length is equal to 10, and then the width is equal to 2/10, which is 20. So the area is 10 times 20, which is 200 centimeters squared, which is option A. So if you have any questions, you can send it in the chat now. In the chat, please. All right. So a few people are being sending the questions in. So let's take a look. So someone asked me to go to the other page. I've done that already. Let's go back to the next page. All right. Some generic questions like about the mock exam and the gate exam. That's not what this is about. I can answer those questions maybe at the end. What does R stand for? So R stands for radius, Kaniska, Kaniskasri. So Kaniskasri, basically, the radius is half of a circle. So essentially, if you draw a circle from the center of a circle to any point, right, that is the radius. Do you understand? I don't understand how you got 100 pi over pi. So Anvika, what I've done here is I've just divided both sides by pi to get rid of pi. Do you understand?
I mean, like, so I don't understand how you got the pi on, like, pi for the denominator.
Do you understand this part?
Yes.
Where did I get this first line from?
From the text, it says,
Good job. That's right. What about this part here?
you doubled it to get the whole circle. You
That's right.
times 50 by 2.
Good girl. What about this?
That's a formula.
For the area, correct?
Yes.
And then how did I get this?
Yeah, I don't understand from that part.
Okay. So essentially, we know what the area is, right?
Yeah.
Then we're saying that the area is equal to this, correct?
Yep. Yeah.
If the area is this and the area is this, then doesn't that mean that this and this are both equal to each other?
Oh, so, yeah.
Do you get it?
Yes.
All right. So because of that, that's why I've equaled them to each other. Do you understand?
Yeah.
All right. And then once they've
Thank you.
equaled each other, I wanted to get rid of the pi. So I divided both sides by pi and then I just solved it. Do you understand?
Yes, now I do. Thank you.
Okay. So someone asked me, why do I divide by pi? Mostly just because we're trying to find out what the radius is. So I'm trying to get rid of everything except for the radius. Do you understand, Sernatha? Sernatha? All right. Yarni, you want to know what pi is? Good question. So pi is essentially, well, I'll first tell you what the number pi stands for. So pi just is a number that is a letter that is equal to 3.1415265358997. Okay, I'm just messing around. It goes on forever. It's a number that goes on forever and ever and ever. But you only need to learn it usually to the first part here, 3.14, right? 3.14. Now, essentially, how do you get pi? The reason the way you get pi is what people found out or mathematicians found out is that if you take a circle like this, and if you were to take a string, Yarni, are you there?
Yes.
Yep. So if you take a circle and you take a string and you measure how fat a circle is, from one side to the other, right? I think maybe a better way to draw how fat a circle is across. Do you see this, Yarni?
Yes.
Yep. And if you were to take that same string and put it around a circle, what they realized was that it goes exactly 3 times and a bit. No matter what circle it is, every single time, if you take any circle, the fatness of a circle, how fat a circle is, fat of or wide fat, I don't know what's a better way to say it, how wide a circle is, right? Which is called diameter, which is how wide it is, right? Diameter is always going to be, if you multiply that 3.14 times, you'll always get the circumference or the distance around a circle. Do you understand? Yarni?
Yes.
Yeah. So if you take how wide it is, it will always be 3 and a bit times around the circle. So that's how you get pi, right? And then over time, what mathematicians realized was that to find the area of a pi, area of a circle, they just need to take the same thing that they found, which is 3.14 times, right? Do you understand?
Yes.
And you multiply it by the radius squared. Now, why does that make sense? Why does that work? So
Okay.
essentially, sorry,
Yeah, it's okay.
sorry,
Yeah, it's fine. You can go on.
I can go.
No, you can go on.
Oh, okay. Sorry. I was like, are you already bored of me? No. So yeah. So why does it make sense? So imagine you draw a circle again, Yarni. So here's my circle. So I'm gonna draw the circle again. Um, oops, that's a bad circle. That's more of an oval. Okay, that's my circle again. And then what did I say the radius was, Yarni? It's literally half of a circle, correct? Yeah. So a radius squared means you make a square that has a length and width of a, a half of a circle. Do you understand? The radius here, radius here. Do you see that?
Yeah.
Do you get it?
Yeah.
And what they found out was that the area of a circle is always, oh, oops, this is a terrible drawing. Let's draw that. Actually, let's draw it a bit better. All right. Oops. Ugh. Sorry, Arnie, 1 second. All right. What they found out was that the area of a circle always, so do you see how, oops, do you see how it fills in this much of the square, this
Yeah.
much of the square, this much of the square, and this much of the square? And then this bit here is left out, this
Yeah.
bit here is left out, this bit here is left out, and this bit here is left out.
Yeah.
What they realized was that the area of a circle is always the radius squared. So one of those squares, one of these, right?
Yeah.
And you multiply it by pi, and you'll always get the area of the circle. You understand?
Yeah.
Do you get it?
Yeah.
Yeah. So that's where we get pi from. So pi, it's always it's basically a number that describes the relationship between how wide a circle is and other properties of the circle. So for example, let's just say, for example, we have James on the call today. So James and Chris. So they're brothers, right? So you have James and you have Chris. The word that describes their relationship is brothers, right? Similarly, pi is what describes the relationship between the diameter of a circle and the circumference of a circle. Do you understand? Do you understand?
I understand.
Okay, awesome. So
Thank
let's
you.
go back. Yeah, you're welcome. So let's go back to the next question. Question number 3. So here we have Archel Boardcar. 1 second. We have Archel, Boardcar, and Cloudstar. And they're all far apart from each other. And it says there's a total distance of 120 and 360 from each other, and 30 seconds and 45 seconds. So, and it's basically asking you to find out the average speed. So if you guys think back to one of our previous week sessions where we went through how to find the speed or distance or time, we learned the distance, speed, time triangle, right? Now, one of my students taught me, so the way I remember how to do it is I know that this is a triangle, and the way to remember it is don't stop thinking. But recently, one of my students taught me another way to think about it is that you say, don't skibbity toilet. And I know a lot of students loved to learn it that way. Whatever makes sense for you, you can do that. So for this question, we need to find out what speed is. So speed is distance divided by time. So in this, the distance is 120 plus 360, which is 480. And then the time is 75 seconds. So the speed is equal to 6.4 meters per second. And if you round that to the closest answer, it is 6 meters per second. So the answer is B. The answer is B. All right. Nice. How do you find time? Time is distance divided by speed, and distance is time multiplied by speed. Awesome. Next question. Pauline swam for 100 seconds at a speed of 2.5, Then she swam for another 100 seconds at a speed of 1.5. Find Pauline's average speed in meters per second. Actually, sorry, before I go on, someone asked me, why do you divide? So a good way to think about it is, a good way to think about it is it Shivani? Shivani, are you there? Can you hear us?
Yeah, I can hear you.
All right. So Shivani, by the way, first of all, Shivani, this is tuition. You had to get up, sit on a table for class. You can't lie in bed. Come on.
I'm a bit sick. That's
Okay.
why.
But in tuition, we have to, respect each other and set up our tables and take notes, right? I won't take classes with students sleeping. So for speed, how would you describe speed? How do we describe it? What's a unit of measurement for speed always?
Okay. Like the
So for example, give me like a common speed. So let's just say you're driving somewhere. What would be the unit of measurement for speed?
kilometers per hour.
That's right. So kilometers per hour, right? If you think about what those words mean, you're saying that your speed, it just describes how far you go for every unit of time. Do you see that? It's basically distance every time. Do you understand?
Yeah.
Yep. So to find speed, you just basically take how far you've gone. To find speed, you take how far you've gone and you divide by how long it took you, and that will give you how fast you go every unit of time. Do you understand?
Yeah.
That's what we divide. All right.
Thank you.
You're welcome. Let's go to the next question. Question number 4. Let's take a look. So Pauline swam for 100 seconds at a speed of 2.5 meters per second. Oops. And then she swam another 100 seconds at a speed of 1.5 meters per second. Find Pauline's average speed, right? So essentially, for this question, the way to think about it is there's a lot of kids who actually no, I wouldn't say kids get this confused. I would say teachers would get confused on this. The reason teachers get confused in a question like this, right, is they assume that you have to find how far they traveled for the first part, then you have to find how far they traveled the second part, and then you divide the distance from the time. But in reality, it's fairly simple. Do you notice that she did 1 lap of 100 seconds of swimming? Do you guys notice that?
Yes.
And then she did a recovery lap of 100 seconds of 1.5 meters per second, right? So the first one was 2.5 meters per second. The second was 1.5 meters per second. But in total, she did 2 laps of the exact same duration. Do you guys notice that?
Yeah.
Because it's the exact same duration, and because it's 2 laps in total, you just take 2.5 plus 1.5 to get the total, and then you divide it by 2. Oops, should draw it like this. Divided by 2, because there's 2 parts, 2 laps, to get the average speed per lap, which is 2 meters per second. The answer is B. So the first lap or the first duration was 2.5 meters per second. The second one was 1.5. So the average is 2. If you guys have any questions, so Nilisha, Rohit, Abhishek, and Dia, send it in the chat. I'll take a look there.
I did.
Do you remind sending it? Or what if you're in America and you use miles per hour? Is that your question?
Yeah,
I mean, it's the same thing. It's just a
I
different
did.
typing it, right?
Mm-hmm.
And
Yes.
then Alicia and Abhishek, or who just said I did. Could you just resend it because I can't find it? All right. So Alicia says, what if the duration is not the same? Good question, Alicia. So let me ask you this, Alicia. So let me ask you this. Let me ask you this. Let me show you this. Let's take a look at a dinner party. So Alicia, Loyola is organizing a dinner party for all the students and parents. Okay.
Yes.
We're gonna have students here, and we're going to have parents, and then we're gonna have cost. There's 10 students, and each student can only bring one parent, so there's 10 parents. And Alicia, would you say that parents eat more food than children or students?
No.
Would you not say that your dad eats way more food than you do?
Oh, yes.
Yeah. So it would cost us $5 per plate for a student, but it costs us $10 per adult. Would that make sense?
Yes.
Okay. So now let's find out how much it costs for all of us, right? So for students, there's 10 students and it's $5 per student. How much do I spend on the students, Alicia?
So, like per student?
No, overall for the students.
For overall, you spend $5.
Nope, I spend $5 per student.
Oh, so overall, you spend $50.
Good girl, 50. And then how much do I spend for the parents?
You'd spend $100.
$100. Awesome. And in total?
In total, you'd have $150.
Okay, so far so good, right?
Yep.
Awesome. Now, on the other hand, and then to find out, and how many people attended overall, Alicia?
20.
20. So we spent a total of 150 and 20 people attended. So per person, we spent about $7.5. Do you understand?
Yes.
Does that make sense?
Yes.
Now, we could have done that without all this additional maths by just looking at this. Do you see how we have the same number of students and parents?
Yes.
So because we have the same number of students and parents, we can just do 5 plus 10. What does that give you?
15.
And then you divide by 2. And what's 15 divided by 2?
7.5.
You understand?
Yes.
Awesome. So that makes sense because we have the same number of students and parents, just like you mentioned. But what happens if the students and parents, the number is actually different? So let's just have students and parents. Let's just say there's 10 students and you bring both your parents, your mom and dad. So there's 20 parents, okay? Can we do the same thing as before, Alicia?
Um,
Can we do 10 plus 5 divided by 2?
yes.
Aha, that's the thing. You can't. Because if you do that, you assume that the average is 7.5, right?
Oh,
But it wouldn't be. Let's take a look. 5 times 10 is
50.
And then 20 times 10 is
200.
200. And the total cost now is
250.
girl. And then how many people attended?
30.
So 250 divided by 30 comes to approximately what? Let me take the calculator for you to speed you.
8.33.
Good girl. Good girl. 8.33333. Right? Now, why did the average go up, Alicia?
Because there were more parents.
Exactly. And parents are more expensive, right?
Yeah.
Yeah. So because of that, in this, you have to do this method. You understand?
Yes.
But in this question here, and then this question here, we just have to find the average because the duration is the exact same, or the number of parents and children are exactly the same. Do you understand?
Yes.
All right. Any questions?
No, thank you.
You're welcome. Let's see. All right. Okay. So, George asked a good question. Why do we not do the same here? Because the time is different. Now, George, the reason we don't have to, the thing is we actually do that, George. So do you see how we added up the total distance and then we add up the total time and then we find the average? Yeah. So sorry, I'm not speaking to myself. He's messaging me in the chat. So that's exactly what we're doing here. And then we find the average. So this is the same as this, George. So this bottom part here. Do you understand? Awesome. The answer for question number 4 is 2 meters per second. All right. Question number 5. A bus traveling at an average rate of 50 kilometers per hour made the trip to town in 6 hours. If it traveled at 45 kilometers per hour, how many more minutes would it have taken to make the trip? So let's take a look. It traveled 50 kilometers per hour and it traveled for 6 hours. So the total distance to go to the town is 300 kilometers. That's a really far away town, right? And then it says if it goes the same distance in 45 kilometers per hour, how much extra will it take? Well, let's see how long it actually takes if you go at 45. So 300 kilometers divided by 45, that gives me 6 hours and 2/3 of an hour, right? So 2/3 of an hour, to find that out, you do 2/3 multiplied by 60. Why do we multiply by 60? Because there's 60 minutes in an hour. So 2/3 multiplied by 60 over 1 is 2 times 60 is 120. 3 times 1 is 3. 120 divided by 3 is 40 minutes. So the answer is B, 5B. It takes an extra 40 minutes.
Melvin.
Yes, but remember in the future, you just send it in the chat, but ask your question.
And by the way, I can't like message in the chat. So anyways, remember when you did like 300 centimeters divided by 45? That
Yeah.
part I didn't get.
Okay. Oh, yeah. As in, do you not understand why I divided by 45, or do you not understand how I got 6 hours?
Yeah, both.
Okay. Why do we divide by 45? So basically, we know what the distance is, right, Vansh?
Yes.
How do we find that out? Because we took how long it took to go there and we multiplied by the speed. Do you understand?
Oh yeah.
And what we did was when we multiplied those together, we found the total the distance.
Yeah.
And once we know the total distance, Vansh, we want to know how long it takes to go at the slower speed. Do you understand?
Okay.
Yes, so that's why we do the distance and we divided it by the speed to get the time, which is 6 2/3.
Oh, okay. Thank you.
You're welcome. Yaksha is asking me, why do we multiply 50 by 60 by 6? So we know they travel at 50 kilometers every hour. Do you understand, Yaksha?
Yeah.
And then it travels for 6 hours, so it's 50 every 6 hours. So the total is 50 times 6.
Okay.
Ellie, I know I'm going a bit slow. I understand that it's frustrating, but it's that I have to make sure that everyone understands. That's why I'm going at this speed, okay? All right, thank you. Let's see. Okay, why did I multiply 2/3 by 60? Well, when you divide it, Hassan, you get 6 hours and 2/3. Do you understand? Hassan, are you there? Hassan? Hello?
Yes, I do.
Awesome. Yeah. So because we found that it's 6 hours and 2/3, we need to find out 2/3 of an hour. Whenever you want to find a fraction of something, you just multiply the fraction by the total thing. Do you understand?
Yes.
Awesome. Yeah, so that's what we did. All right. Let's take a look at the next few questions. What percentage change in the number of students in branch B from year 4 to 5? Or what is a percentage change? So in year 4 in branch B, we have 125 students. And then in year 5, we have 200 students. So that's an increase of 75 students. Do you guys understand? So to find out the percentage increase, it's 75 over 125 because you start with 125, and that is equal to 3 over 5 because I simplified it, which is equal to 60%. 60%. Question number 7. By what percentage is the total number of students studying in branch C more than those studying in branch B? So the total number of students studying in branch B in year 4, let's see, year 4 is 225. And then branch B in year 4 is 125. C, B, what's the difference? There's 100 more students, right? The difference is 100 students, right? Between them. Let's do it this way. The difference is 100 students. So what percentage difference is it? So it is 100 divided by 125. And if you simplify that, you get 4 over 5, which is 80%. So the answer is C. The answer is D. All right. Up next, what is the percentage change in the number of students from branch B from year 2 to year 3? So in year 2, branch B had 150 students, year 2. In year 3, they had 125 students. So that was a decrease of 25 students, right? And then it started off from 150. So you have to find out 25 over 150, and that gives you 1 over 6, which is 16.67%. 16.67%. Question number 9. What is the ratio between the total students in branch A from year 1 to 3 to the total number of students in branch C from year 3 to 5? So if you add up the total number of students, which is, let's see, 125 plus 170 plus 110, you get, let's see, where did I have that open? Did I have that open somewhere here? Is it, well, let's just,
295.
sorry?
405.
Awesome, 405.
Mhm.
I just have this open so we can save time. All right. Yeah, so you have 405.
Yeah.
And then branch C from year 3 and year 5. So remember, this is another common mistake that you might have made. Here it says 2 year 3, and then year 3 and year 5, it is 225 plus 220, which is 445. So 405, 445. The number that goes into both of them is 5. And when you simplify both sides by dividing by both sides by 5, you get 81 and 89, giving us C. All right. In question 6, why wouldn't you do 75 over 200? Good job. So James asked a question in question number 6, why do we not do 75 over 200? So James, the question, so whenever they ask percentage change from year 4 to year 5, right? Basically, it's saying that imagine you're in year 4, by what percentage did you increase to go to year 5? So the denominator has to be the initial number, which is 125 in year 4. Do you understand?
Yeah. Thank you.
You're welcome. Question number 10. Compared to year 5, the number of students in branches A, B, and C increased by 10%, 12.5%, and 15% respectively. What is the difference of total number of students across the branches in year 6 and in year 2? So this is really easy. All you have to do is increase the year 5 by these percentages. So how would it look like? So year 5, I'm going to need a helper. So I'll get, let's see. Michaela, can you help me out? All right. So Michaela, can you tell me what branch A numbers in year branch A numbers in year 5 was?
J numbers in year 5. Like, where's my
branch A numbers.
I can't find my book now?
Oh, that's okay. Do you have your booklet in front of you?
No, I can't find it.
Oh, okay. So how about this? You can tell me there.
Okay, so branch A numbers in year 5 would be 180.
B.
B. B would
Branch
be 220.
200 actually.
200. Oh, looks like a 20. Okay, 200.
And then C.
220.
Good girl. All right. And then it says branch A increases by 10%. So to find that value, you multiply by 1.1. Now, why do we do that? So you take 100% of all students in branch A in year 5, and you increase it by 10%. So 100% plus 10% is 110%. And 110% as a decimal value is 1.1. So when you multiply that out, you get 198. Branch B, how much does it increase by, Michaela?
B has increased by not sure.
So it's in this line here.
Oh yeah, 12.5. 12.5.
So if it increases by 12.5%, you take the initial 100% and you add 12.5%. So that's a total of what percentage?
Total no.
100% plus 12.5%.
One 112.5%.
And that as a decimal value will be 1.125. And that gives me 225.
Mom, can you please shut the door?
Sorry? Okay, must be an accident by Pravina. That's okay. Pravina, you can help me with the next one. Branch C increases by how much?
Branch C. Just a second. Branch C.
You can, it's on the board. You can take a look at this line here. Maybe that helps.
Branch C 15%.
Girl. So we take the initial 100% and add 15%. So what's that equal to?
Pardon?
You take the initial 100% and you add 15%. And what's that equal to?
115%.
And what's that as a decimal? So 15% is 0.15, 100% is 1. So 1 plus 0.15 is 1.
Is 1.15.
Girl. And then when you multiply that out, you get 253. So if you add them all together, you get a total of 676. So that's the number of total students in year 6.
Yeah.
To find the total in year 2, you just add them all up and you get year 2 total is 570. And if you subtract them out, you get 106.
6.
Awesome. So let's take a look. Let me just read the chat. All right, so a few people are asking me question number 9, how did 405 and 445 become 81 and 89? So Januja, do you understand how I got 405 and 445? Do you understand this line here? Hello? Januja, you're there? Yeah, do you
Yeah.
understand how I got that?
Yeah.
Girl. And then the next thing is you have to ask yourself, what goes into both of those? What number will go into 405 and 445? What number goes in? The girl. So you divide both sides by 5, and that's how you get 81 and 89. Do you understand?
Yeah.
All right.
Thank
Why did you divide both sides by 5?
To simplify it, to get to the simplest ratio.
Oh.
All right. So that's this page. I'll leave it up for a few seconds before going on to the next page.
Thank you.
Melvin, in class they told me the answer to
So
question
sorry. I'm so
7.
sorry, Tej. You'll have to send it in the chat. So as I mentioned, I'm not taking questions over the microphone because it's unfair for everyone else. You can send it in the chat and I'll take a look. All right, so I'll leave it up here if anyone wants to take any notes before I go on to the next page.
Melvin.
I'm so sorry, Janel, you have to send it in the chat as well. All
What if
right.
you can't chat? What if you can't message in the chat?
Not an excuse. You'll have to figure that out with the help of your mom and dad. That's a technical issue. I can't help with that.
They already tried.
Then I'm sorry, Vanshu. I still won't take students' questions over the microphone. It's just unfair and it just gets very, very loud and disruptive.
All right. Try
All right.
one more time.
Next set of questions, let's take a look. So for this one, it's fairly straightforward, but yeah, let's just go through it. How many students are studying computer engineering or mechanical engineering? So remember, when you're saying or, you basically just have to add them both, right? Can I help you? They can raise their hand. I enjoy doing this. Awesome. Do you? Yeah, I do. All right, so let's take a look. So computer engineering, we know that there is 16%. So 16% of 900 students is equal to 144. And 18% of 900 students is equal to mechanical engineering, computer engineering. That's equal to 162. Oops, not 66, 62. And if you add them together, you get 306. So the answer is C. Pretty easy question, actually. All right. Next, let's take a look at question number 12. 50% of students in chemical engineering and 25% of students in IT plan to go for a picnic. If only 5/8 of the students who actually plan to go actually go, how many students went to the picnic? So for this one, let's find out how many students are in chemical engineering. So chemical engineering, there is 16% of the total population. Sorry, not 16%. Is it 16%? No, sorry, 20%. My bad, 20%. 20% of 900, and that's equal to 180. And then IT, the population of IT students is 8%, which is let's see, 72. And only it says wait 1 second, what is it? Yeah, it says only okay, actually I'll need to do it step by step. That'll make it easier to follow through. So let's just let's just get rid of the bottom line. So let's just do the first thing. We know there's 180 students in chemical engineering. Now, out of them, only 30% of them plan to go. So what is 30% of 180? And that's equal to 54. So now we have to do the same thing for IT. There is 8% of the total population of the school is IT, which is 900 students, and 8% of 900 is 72. Out of them, it says 25% of them plan to go. So 25% of 72 is equal to 18. So now we know how many students planned to go on the trip. So it's 54 plus 18, and that's a total of 72 students, right? So 72 students planned to go. But out of them, only 5/8 of them actually ended up going. So we need to find out 5/8 multiplied by 72. 8 goes into 8 once, 8 goes into 72 9 times, 5 times 9 is 45. So the answer is 45A. Fairly straightforward, right? So I'll leave it up here. All right. Question number 13. The ratio of males to females in IT is 5:7. The ratio of females to males in electronics and telecommunication is 5:4. What is the difference of the number of females in these two branches? So earlier on, we found out that the number of people in IT is 72, right? And we know that it is 5 males to every 7 females. Or another way to think about it is males to females in IT. We know that it is 5:7. Or another way to think about it is 5/12 male and 7/12 female. So to find out the number of women or females in IT, it is 7/12 multiplied by the number of people in IT, which is 72. That gives me 42 females in IT. Now, telecommunications, we know that telecommunications is 27% of the university. So 27% of 900 is equal to 243. And then the ratio of males to females, the other way around, you have to be careful, of females to males is 5 to 4. Or another way of saying it is that it is 5/9 to 4/9. And to find out the number of females in telecommunications, you do 5/9 multiplied by 243, and you get 135. So you do
Melvin, for the fractions, isn't it supposed to be 5/14?
No, it's not. Because there is 5 males for every 4 females, so there's a total number of parts of 9 parts. I think you might have got confused because my handwriting, this looks like a 9, but this is a 4.
Oh, my bad. Thank
So
you.
that's all good. Yeah, so 5 nines of 243 is 135, and then 135 minus 42, that gives me 93. So the answer is A. The answer is A. And finally, question number 14. Question number 14 basically wants to know which branch will have the most number of male students. Now, this question is really easy. Like, you don't have to do any maths for this. Obviously, the branch that has the highest number of students will have the highest number of males, because it says that all of them are equally divided by male and female. So the branch that has the highest number of students is electronics and telecommunications. So the answer is D. Really, 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 really easy. Januja, where did I get 72 from? 72 is the number of students in IT. So we solved that in the previous question. That's how I got it. Do you understand?
Yeah.
All right. Question number 15. Females form 55% of the total population of the college, 70% of the strength of the chemical engineering batch. The number of females studying chemical engineering approximately form what percentage of females studying the college? So, well, first let's find out how many females there are in the college. So 55% of 900 is equal to, let's see, 495. And then we know that from an earlier question, so this question here, that there is 180 chemical engineering students. So 70% of 180 is equal to 126. So to find out the percentage of chemical engineering students as a percentage of the total females, you do 125 divided by 495, and you get approximately 25%. The answer is D. And the final question, the one we were all waiting for, this question was really funny because a lot of people get confused about this.
No, can you go up a bit, Melvin?
Of course.
Thank you.
You're welcome. All right. So for this question, super easy. We know that this bottom part is 25. Now you must realize that these lines all are also the same distance. So there is 2 25s. And then we realize that this side is the same as this side. So there's 2 10ths. And then we realize that this side, oops, I'll use a different color, I'll use pink. This side, actually pink is invisible, but blue. This side is the same as this side. So there's 2 12s, which is 24, and you get 94 centimeters. Pretty easy. Easy peasy lemon squeezy. All right. So that's it for today, guys. If you have any questions, send it in the chat. If you have no questions, you can go home, play Roblox, watch YouTube, whatever year 5 students do. Yeah, have fun. I'll see you guys next week.
Bye, Melvin.
Bye, Melvin.
Bye, Melvin.
Bye bye.
Bye, Melvin.
Bye.
Bye, Melvin.